Hi, my name is Mike Lawrence. This video is one of a set which is intended to provide a different interpretation of the experimental results that constitute the foundation of current physics. It is clear that the present explanation for what we see in the universe is good in many ways, but it is missing an overall coherence. My view is that we need to look at physics with new eyes and consider an interpretation that explains most things well, even if it does question just about everything. I do not disagree with any experimental results, only the interpretation of those results. And I do not say that the hypothesis that I'll be talking about in these videos is the theory of everything, and that everything I suggest is correct, but it is a start. Each video in the set will cover an aspect of physics. The whole set needs to be understood together in combination, because many aspects rely on each other, and any one taken on its own may not be convincing to those relying on the current interpretations, some of whom may actually be offended by the hypothesis. There will be links in the videos to other videos in the set that cover closely related or overlapping aspects. Within the boxes in the videos are representations of the motions of the particles and their composites, which I will be explaining more fully. I'm happy to answer questions where I can, perhaps providing links to where a deeper mathematical analysis shows why I say what I do, since equations and graphs do not make good videos, and will post replies where appropriate on Twitter. I hope you enjoy the videos and they enable you to better appreciate the absolute symmetry and simplicity of nature. But please remember, I'm not an experienced presenter, and although I state everything as if it were correct, this is only a hypothesis. This is video number 25, Loop Symmetries and Stack Formation. Loop stacks are all particles that are not single fermion loops. This means baryons, mesons, photons, WZ, gluons, and the Higgs boson. Whilst the nucleons have odd numbers of loops, the bosons have an even number. The number of pairs in a loop define how many asymmetries are needed to form a stable stack. These asymmetries are what is called the color force, and a stable colourless stack is one in which all the required asymmetries are balanced along the stack. Bosons are not force carriers. The merged pairs take that role. What this means for the Higgs boson is that it is a stack of loops. Whether these loops are themselves loop stacks, or just loop and anti-loop, or bottom quarks, WZ, gluons, taus, or muons, is immaterial. The Higgs breakdown products may vary, but provided the component loops match the mass expected, and there are an even number of them, that is fine. The issue is that the Higgs has nothing to do with producing mass in other particles. It is just a boson, and there is no special Higgs field. What produces mass is the effect of chains formed from the background merged pairs which attach themselves to the unmerged muons as the latter rotate in their loops on the local background. It is only these background merged pairs that transmit forces, with the force being transmitted depending on the type of merged pair vibration or rotation within the chain and the loop rotational rate. A stack formed by an electron and a positron, both spinning plus a half, it's rotating in the same sense next to each other, is a photon. So a photon is a matter-antimatter composite, where the positive muons in one loop are trying to reform their original merged pair with negative muons in the other loop. In this instance, they chase simultaneously around the loop and from loop to loop. Their maximum transverse external velocity is set by the density of the local background, which we call light speed, since the background acts as a form of viscosity, opposing all motion and providing an arrow of time, and no motion is reversible without further energy loss. Because our matter loops contain three unmerged pairs of muons, their symmetry is threefold. Other pair number loops have different symmetries, and so stacks containing different pair number loops cannot successfully balance their symmetries or asymmetries to form a stable stack. The symmetries are based on the position within loops of the 1/6 twist-generated charge. For a neutrino with no overall charge, the most symmetric version is with all the muons twisting in the same spiral sense. This would produce positive muons generating positive 1/6 charges, with negative muons generating negative 1/6 charges, or vice versa. This gives the charges around the loop as plus minus plus minus plus minus, which is threefold symmetric, but also completely symmetric. An electron loop, by comparison, will have the positive muons twisting one way and the negative muons twisting the other. The result would be minus 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 minus. The reversal of twisting directions will produce the positron, both loops being threefold and completely symmetric. The loops with complete symmetry are balanced and can thus exist on their own or within stacks. Quarks will have mixed twist spiraling directions, and the up quarks will have only threefold asymmetry, while the down quarks will have threefold and further asymmetric versions. The neutrino also has asymmetric versions. So to form a stable stack requires one loop of each asymmetry plus any number of symmetric loops. For a stack, even if the asymmetric loops have the correct asymmetries, those loops also need to have a total charge of either 0 or the size of charge equal to that of the largest charge single loop of the same pair number. So for threefold symmetric loops, the maximum charge is 6 correctly twisting muons, totaling a charge equal to the electron or positron. Since symmetric loops do not change the overall total symmetry of the stack, they can be held within the stack, if of the correct pair number. So electrons and neutrinos can exist within nucleon stacks and can themselves form stacks. The asymmetry of loops is what underlies the colour force, but colour is actually the rotational asymmetry of the mass and charge forces acting directly between muons within stacks. The strong force is the same force but acting across nucleon stacks in a nucleus. Only odd pair number loops can form atoms and produce chemistry, because total loop spins in stacks whose loops alternate spin orientations will always sum to positive or negative spin a half. This spin needs to be balanced by an orbiting loop of the opposite sign, total charge and same spin size. Stack loops are usually of the same size, that's radius and frequency, in order that the rotational symmetries can be balanced along the stack. A change of loop constituents in a stack will result in a change in the stack frequency, meaning the stack's overall mass. Stacks where loops alternate their rotational orientations, that is their spins, are slow moving and tend to have net spins. Examples will be pions, nucleons, and, with no net spin, zerons and some pions. Those stacks where all the loops rotate in the same sense move quickly, for example bosons and photons. Related videos will be 27, what transmits forces, and 15, dark matter analysed. Thank you for watching.